It's always nice to try to communicate science in a way that engages people. So trying to bring it around to a story or connecting it to an activity or something that people are engaged in their day-to-day life. Because it starts that emotional response and, oh, they care, rather than it just being this abstract thing that the scientist wants to talk about.
Mathematically grounded science, it's not accessible to a lot of people unless they're interested in that. It's such a balancing act between the science and the community needs.
I'm Eric Oliver, and I work in physical oceanography and climate studies. I try to understand how the ocean and the climate varies from day to day and year to year and week to week, and if we can predict it. So that's an extreme event. But then you've got communities here. And in particular, I've been looking a lot at extreme events, marine heat waves being a main one. That has a clear effect on coastal communities that rely on fishing or tourism.
First, I would like to understand these events before I can actually go out there and say to the people, okay, this is what's happening to you and this is why it's happening to you. So they can be better prepared in the future.
The other project that MEOPAR is supporting is for the community-based observing of Nunatsiavut Ocean Circulation Project. So that's a big project that involves community workshops in Nunatsiavut where we're doing participatory mapping with community members.
So we wound up with these 9-foot by 21-foot long maps. So people came down to the community hall and see these maps that are absolutely massive, taking up the entire space of the floor. And you just kind of get sucked into them in a way. Immediately they kicked their shoes off and were crawling around on them and finding their home and finding their community.
The red lines are winter travel routes. The green lines are ocean currents. The blue lines are areas of unsafe ice. And then the black lines are the edge of the fast ice.
Mobility is something very integral to Inuit culture. To use mapping as a way to document that knowledge, you're really capturing the spatial aspects of their knowledge.
Interdisciplinary usually means between different disciplines, but I think that the same ways of thinking about interdisciplinarity map onto different knowledge systems. So also trying to bring together, say, Western science approaches with local indigenous knowledge. So right on this tip was where their summer home was, and would have salmon fished all along here and here. This is the salmon river. I grew up in Labrador. My family is from there. I'm personally a mix of Inuit and European settlers, and so I can see how science is a way of understanding the world, but also being steeped in that culture, I can see how there's another understanding of that system. I had always heard that the sea ice patterns had changed. The scientific side that I'm bringing to that is to use a numerical ocean model to simulate the ocean and the ice of that region. And then we interviewed people in the local community and mapped the changes that people had noted. The local knowledge is actually useful as a way of saying, well, this is what the observations tell us, and we can use that to have confidence in our model. So if people want to travel down that coast, they can cross the ice bridge and go. But if this ice doesn't form up, like this year it formed really late, then it's like people are stuck way out on a peninsula. And in order to get out here, people have to travel all the way back and come up. And likewise, to get out there.
Initially, when mapping was really used in Canada, it was to define territories and claim resources, and it was a very colonial sort of process. And the mapping that we wanted to do was exactly the opposite of that. We wanted to document Inuit knowledge of a certain area.
So a scientist has a funded research project, and they do their research and they publish a paper, and that traditionally is where that knowledge has ended. So I think knowledge mobilization is around trying to facilitate the best way of moving that knowledge from just the scientific community into the general public. It's actually becoming less and less frequent that the younger generations are spending time out on the land with the older generations. And so that knowledge transfer that normally happens out on the land isn't happening as much today. And so it was expressed to us that a good way to facilitate that knowledge transfer could be to have the knowledge in different forms.
We're working on designing a travel booklet based on the knowledge that we're documenting with elders in the community. Waterproof and pocket size so they can carry it when they're out on the sea ice.
Of course, we want to talk about climate change and 1.5-degree warming and that kind of stuff, but that gets very abstract and it's hard to connect with. Trying to link climate change to something that is relevant and engages them is a really good way, I think, to communicate the science because it starts that emotional response.
For Inuit specifically, storytelling, it's the way of sharing knowledge. And so when you can align science with storytelling, you're kind of mimicking a traditional way of transferring knowledge as well.
Because we are not working only to satisfy our curiosity. We're not doing science just for the sake of science. We're there to help people.